can probably go ahead and get started.
Okay, thank you, Matt. Randy, can we start recording? Cool. Good morning, everyone. Thank you for joining in today's seminar. I'm Preeti Roy. I work with Dr. Matthew McAuliffe on the BRICS project. And before we start, quick few things regarding the logistics. So today's session will be recorded and it will be posted on the BRICS website, mentioned in here on the URL that you see on the screen. As always, we encourage you to participate and ask questions. So you can use the chat window for posting in the questions, and we will be monitoring the window throughout the session and answering as we can. And also, after each presentation, you will get a chance to ask questions. You can raise your hand or unmute yourself and ask in between. With this, I'll hand it off to Dr. McAuliffe to introduce our presenters and the agenda items for today.
Good morning. Welcome to the new fiscal year. It's been a busy year for us, and we look forward to keeping busy over the next year. Also, we got a new contract in place, funding in place, so it's going to be a very exciting year as far as development and adding new features and improving performance. We not only build the BRICS proper platform, but we also build a number of tools that help support different aspects of the BRICS platform for getting data in, supporting other data models, and those kinds of things. So today we're going to talk. We have four excellent talks by Drs. Ogo, Volk, and Bokinski and Bogonis. The first talk is going to be about some of the work that we've done with FHIR. There's lots of other work that's going on, but this is a specific part of it where we actually take a FHIR profile and convert that automatically or programmatically convert that prior FHIR profile to common data elements. That allows us to have data submitted either in bulk format or connecting into a FHIR repository, getting that data and then putting it into our database. We'll also be talking about UMLS and the importance and how it helps supports making our data more reusable. Whenever possible, we use common data elements, but sometimes between the different BRICS instances, they use data elements that have similar concepts but aren't necessarily exactly the same. But having the UMLS CUI or concept UID attached to them allows us to now start to tie together data semantically over the different instances. And you'll see, Olga will, or Dr. Volk will talk more about that. And then you can see some great updates to the tool from Dr. Bokinski. And then lastly, we've been working on a tool. We've had a tool for a long time that helps get data or legacy data into our system. It's a semi-manual tool to translate data from one format into the BRICS format for submission. But Dr. Bogonis has been doing some great work on more automating that process, and she's going to talk about that. So with that, I'm going to hand it off to you, Henry, and you can take it from here.
Thank you, Matt. My name is Henry Ogo, and today I'm going to present the work we've been doing on FHIR. This is part of a larger effort that aims at enhancing the tool stack and the capabilities within BRICS to create an opportunity or an avenue that can seamlessly ingest, integrate, and exchange FHIR-enabled or compatible data between BRICS and other biomedical systems. Next slide. So what you're seeing here is part of the larger effort that I talked about. You see FHIR on the left, and on the right, you see all the tools or modules within the BRICS ecosystem. There are so many different great tools for my biomedical research, like the data dictionary, the data repository. We have a query tool and a meta study tool. Then in the middle, you see tool that we use for ETL and so many other great stuff that enhances biomedical research. There are a lot of benefits to create all these FHIR tools within Brix. I'm going to present the bigger picture. Then from there, I will zoom in on this particular tool that we're going to demo at the end of this talk. Next slide. So what you're seeing here is the big picture. And the goal here is that we creating that environment within Brix such that the Brix ecosystem will be able to ingest via formatted data from external sources. And also external sources will be able to ingest the FHIR data from Brix in a seamless fashion. So if you see the swim lane that says FHIR to Brix, this is where the source of data is. And as most of our viewers or participants are aware, before you submit any data to Brix, the system ensures that data conforms to structures we have within the data dictionary. The two most important object or component in the Brix data dictionary is the data element and form structures. Conceptually, the form structures is a container that maps to the instrument that we use or researchers use to collect data. It could be a case report form, a survey instrument, or a questionnaire that maps to a form structure. And of course, your questions or answers or data elements are part of it. The good news is that philosophically, FHIR also has resources, and that these resources are also containers that also have data elements that are used to collect data for data exchange. So because there's a like for like, we did a mapping between the resources and the Brix form structures. Now, a resource is a FHIR resource is a general thing, but the US core have created profile that constrains the resources. So what we did was that we created a tool that will pick a FHIR profile, a US core profile, and the tool does two things. First, it extracts all the data elements within the profile, and two, also convert the profile into a Brix formatted form structure. And these two separate files, a user can import them into the Brix data edition. I'm going to demo shortly how that works. And once that is done, a user or an external system can always import data into the Brix repository. And the Brix data upload and validation tool will, there's a series of validation that, or checks that it does to make sure that the data that is coming in has mappings to form structures within the data dictionary. So without further ado, I'm going to demo the tool. But before I do that, let me just show you a very simple construct of how that is going to look. Thanks a lot, Preeti. So what you're seeing here is how the tool works. That basically, I know this has been well simplified, even though a lot of things go on behind the scenes. So what you're seeing here is a US core profile for the patient resource. And this is a structure definition file in a JSON format. So the tool will ingest this data as input, and like I said, it will convert it into a bricks formatted form structure that can be easily uploaded into the data dictionary. I'm going to demo how this works using the web version of the tool. So the good news here is that we have two versions of this tool. We have a web version and we have another one in Python. And for heavy users who want to create a pipeline that can do this seamlessly, you can actually leverage the API systems or endpoint within Bricks to be able to do that. That you can just develop a Python or R or any application that will once again ingest a US core or any profile, and it should be able to convert that into a data additional, that into a data element and form structures in a very seamless manner, and also be able to upload them into the Bricks data dictionary. So let me demo how the tool works. Pretty, can I take over your screen? So, like I said, this is the web version of the tool, and it should be available on the Bricks site. If you go to what is Bricks, there are a slew of tools over there, of which this is one. Okay, so this is the tool that I'm going to demo, and it can be launched from here. Here, I'm going to select an input file. So go here. Pick Bricks. Sorry. So I'm going to demo with the patient profile. So I pick the patient profile. I mean, this is a JSON file. I don't want to bore anyone here with the details of it. So we select it and we click the generate button, and oh, good. So that was pretty fast. So it has generated the files. So I can go here. Oh, sorry. So let me extract this. So yeah, basically this should be the list of data elements. Okay. So what you're seeing here, these are the list of data elements from the profile that were converted into Bricks data elements, and they'll be ready to go into the system. The next one, this is the profile in the JSON format. So we're good to go. And like I said, with just these two files, you can create a form structure within Bricks via the web tool or the API. So let me go here and okay, use this tool. Okay. So I'm now in the Bricks data dictionary tool. Okay, let me quickly do this. Okay. Okay, so I can import the data element. So all the data elements have been imported, and they are all in red because they map to probably similar other data elements within the system. I can also use the same system to import a form structure. Yeah, that was successful. Great. So I can go here and search for it. So over here, okay. Okay, so here we go. Good. Yeah. So what you're seeing here is the US core patient profile that has been converted into a bricks form structure. And what you're seeing here, the metadata, these are the metadata information that you find in the structure definition file. These are also the list of data elements within the profile. And you see, like I said, majority of them are one-to-one mapping between the profile and the form structure within bricks. Yeah, so this is the tool, and like I said, this is the web version of it. We also have another version in a Python format that power users can integrate into their pipelines, an end-to-end pipeline that can easily ingest the structure definition files and convert them into bricks form structures, and at the same time use that same pipeline to upload them into the system. So this is what we have, and like I said, this is part of the larger effort. Thanks a lot, and at this moment, I'm more than happy to take your questions. Thank you.
Thanks, Henry. That was awesome. If there are any questions, I think we have time for one question. And but as always, you can reach out to our group independently, and we're more than happy to, provide as much information as you need. But if you have we have a question from Leonie. Why don't you go ahead and come off mute and ask your question?
Hey, good morning, everyone. Hopefully you can hear me. The very, very interesting and very nice transformation. One quick question. US Core, of course, as part of the profiles, have these data elements defined. I'm going to use gender as an example. So gender exists in bricks already. And gender, as you pull it in from US Core as an example, do you keep both versions, or do you actually say, one is recommended by US Core and therefore takes precedence when you are using it within the system?
Yeah, maybe I can jump in and answer this question because it's a little bit broader. Is that, any instance of bricks can have its own data elements and or data model. So if you wanted to just have a FHIR bricks repository, you would just load up the FHIR data elements and collect the data consistently. If you have other data in the system that uses that other data element, We have both data elements in the system then, but this is a great question because it's a lead into the exact next talk with Olga, and we link those data elements because conceptually they're the same, conceptually they're the same concept, and we used the UMLS CUIs to link those data elements that are similar together. So with that, I'm going to hand it off to Olga.
Good morning. Preeti, do you want to present?
Sure, I can bring it up.
Thank you.
Let me know when you guys can see it.
Yes. So the topic of my talk is how we use a unified medical language system in our data dictionary, and in particular to make the BRICS data dictionary fair and even more fair. So the next slide, please. So the BRICS data dictionary, we built it based on that means we are using common data elements, and data elements have unique identifiers, and we supply our data elements with rich metadata, and metadata is publicly available, and our BRICS vocabularies are also publicly available. And we also, when we provide metadata for our data elements, we trying as much as possible to incorporate standard controlled vocabularies. That allows us, the BRICS as a system, that allows us to effectively find, query, and report data, and it also provides support for exchange data between independent informatics system, as we just seen with our BRICS on FHIR tool. Next slide, please. So, and BRICS data dictionaries are big, and in particular, our FIDBR data dictionary has about 9+ thousand published data elements. And across BRICS data dictionaries, we support different data models and standards. And because these our data dictionaries are so big, we were trying to find the tools, develop the tools, and find the means to make our data elements more searchable, more connected, to provide richer metadata. And recently, we decided to map semantics of our data elements to UMLS concepts and concept identifiers, and that answers the question about gender data elements. So, for example, if we have some data elements imported from external vocabularies, plus our data elements which have similar semantics, we decided to map this, to connect these data elements and make them searchable and more findable. And to connect data, we decided to use UMLS concept identifiers and supply our data element metadata with these concept names and concept identifiers. Next slide, please. So why we choose UMLS among other terminology sources? First, because UMLS is developed and supplied by National Library of Medicine. It incorporates more than 200 different terminologies and vocabularies. And it brings together vocabularies from different terminologies. So instead of picking up some certain specific terminology, which has its limitations, we decide to use UMLS concepts as our main terminology source to map data elements. And the next slide, please. And what we've also done, we provided the search in our data dictionary by biomedical terminologies. There one can enter the concept identifier or concept name and get the result, all the data elements which semantics have been mapped to this concept. And as a result, we made our Briggs dictionary more AI ready. We make our data elements more searchable. And the most important thing, we developed the data element to UMLS quiz mapping tool, and already mapped about 3,000 data elements across Briggs vocabularies, which allows us to connect elements from data elements and data from different Briggs instances. And now it's Alexandra who will show the UMLS mapping tool. Thank you very much.
Thank you, Olga. I'm Alexandra Bokinski, and I've been working on the UMLS mapping tool, which I will talk about real quickly and then do a live demo. Can we go to the next slide? Okay, great. So the UMLS mapping tool is designed to help users easily find those UMLS concepts or CUIs that fit their data elements, and then save that output as a file that we can upload into the data dictionary. Like Henry just showed, we can upload a CSV file directly into the data dictionary to create or modify data elements. So the UMLS mapping tool also allows you to take a CSV file from that data dictionary, generate those CUIs, select the ones that are appropriate for you, and then re-upload that easily into the data dictionary. And in fact, new to the tool is you can launch it directly from the data dictionary, and I've highlighted that button in red here. Next slide, please. So the UMLS mapping tool, we use the National Library of Medicine's API to connect directly to the Metathesaurus, which contains, like Olga said, over 1 million biomedical concepts from, I guess, 200 source vocabularies. So it provides quite a bit of context for that. We also connect to the UMLS Semantic Network. And the Semantic Network is a group of 133 broad categories that sort of label the biomedical domain. And so those categories help the user better understand which concept is right for them and which one maps directly to their data element. And so we've added a semantic network visualization that helps the user better understand those semantic types as well. So in this slide here, it's just a screenshot from the tool. I've typed in the search phrase traffic accident due to substance abuse. I just typed that in directly. And you can see the first row of results is traffic accidents. You get the concept, it's highlighted, the first row. You see the concept, the unique identifier or CUI. We list the definition, the semantic type, and the vocabularies. The second row is also a pretty good fit. It's substance abuse problems. It gives you the CUI and so forth. So I can highlight the CUI for traffic accidents. And if I copy that and go to the next slide, I can paste it directly into the data dictionary, hit return and search and find all the data elements that are currently annotated with that CUI. And you can see that there are so far 6 of the data elements in FIPR that have been assigned this CUI. And so it's a pretty good match. And as we add more annotations to those data elements, we'll get more and more accurate results. Let's see, go to the next slide, please. We can also take that CUI and drop it into the visualization that we have for BRICS repositories. And if we pasted it into the UMLS search tab, it'll also bring up the same list of FIPR data elements. And it also shows you what else is available. You can explore the form structures that use those data elements that have that CUI. You can look at the studies and a bit of demographic information, all related to filtering the BRICS data by that UMLS CUI. And so as we add more and more annotations to the BRICS data elements, this will become an even more powerful tool. Next slide, please. Another quick example, I typed in the search phrase alcohol consumption, and you can see the first result matches exactly alcohol consumption. The second result is binge drinking, which is also an interesting result. If I, again, take that CUI for alcohol consumption, go to the next slide, and I just drop that into the data dictionary, we get, I believe, about 19 results related to alcohol consumption. And these are, again, data elements that have been annotated with this UMLS concept. And we go to the next slide. And in the data discovery tool, again, I've searched by the CUI for alcohol consumption. And you can see here I get another list of data elements. But since this is searching across BRICS repositories, you can see that it doesn't just include FIPR, but it also includes PDB results of data elements from PDBP and CDRNS. Next slide, please. So the UMLS mapping tool has a bunch of features. So we can do keyword search, concept unique identifier search, and the batch data element upload, where you upload the CSV file. So what's new? This is an update to the tool talk today. So we've added the ability for the user to select the search category when they upload their file. And I'll demo that shortly. And we've also added the interactive visualization of the UMLS semantic network, which is highlighted in this slide. So the network has broad categories. The two main categories or branches of the tree are event and entity, entity and event. And then as you go down the tree, they get more and more specific. And so each UMLS CUI is, or concept is also placed within the semantic network category. And so as you're assigning a CUI to a data element or picking the one that's right for you, it's good to you can refer to the semantic network, get more information about the particular category, and help make that decision. So I'm going to next, we can go to the next slide, which is the demo, and I'm going to, if it's all right, share my screen.
Yes, go for it.
Yep. Just a quick, but we're running just a little bit behind schedule, so. Yeah.
I've already done all the searches, so we don't have to wait. They run pretty quickly, but just a quick overview, and definitely keep me on track, Matt. So I've typed in alcohol consumption. You can highlight the row, get this CUI. The definitions are based on the vocabularies that the user selects in the filter panel over here, and we've pre-selected a few that fit pretty well for BRICS. So the user doesn't have to get started, but they can modify those. If you hover over semantic type, it gives you a little bit about the definition of that semantic type. This one's individual behavior. It shows some examples, and then the vocabularies here. Now, if I won't, since we're short on time, I was going to show you that if I search for binge drinking in the data dictionary. It doesn't exist yet, but hopefully it will at some point. If I go here and I just drop this CUI for alcohol consumption in the data dictionary, it's going to process pretty quickly and show you those 19 results. If I click on one of these data elements here, it's going to take me to the overview page. You can see that each data element is labeled with up to 3 CUIs to help better define that data element. And if say you're in the data dictionary and you're looking at a data element and you come across a CUI and you're not really sure what that means, you can go back to the mapping tool, go to the CUI search tab, and just paste that in. And so that'll do a search on the CUI. It's going to show you its concept, its semantic type, and its definition. In the batch search tab, the user is able to upload a CSV file, the same CSV file, very similar to the one that Henry showed in his talk. And so I've just gone ahead and pre-uploaded a file. It has 4 different data elements. I've selected one and done the search, but already, and I'll show you the results in a second. But
we're going to have to we're already 5 minutes over, Alexandra. Okay. So if you just want to, we can just tie it up.
Sure, no problem. So you can select the column that you want to search on, go ahead and do that search. And then the new thing, and I'll leave this, it's available for anyone to explore, is the semantic network. It's an interactive tool that lets you visualize the data. If you hover over a particular semantic type, it shows you information about its location in the tree, the network, its definition, examples, and notes as well. And I'm happy to answer any questions if there is time.
Yeah, fortunately, we don't have time, but I encourage anyone who is part of the meeting to reach out to Alexandra or to the BRICS team, and we'll provide as much information as you need. This tool is going to be available on the BRICS website soon, so you can play around with it, kick the tires, and we're more than happy to get some feedback and usability improvements. So thanks really, both Olga and Alexandra. This is really great. And this is kind of like the last version was beta, and now this is version 1. The tires have been kicked by Olga, and we've really tested it. So it's really a nice tool now. So thanks again to Alexandra and Olga and the rest of the team too. So with this, I'm going to hand it off to Maria, who is going to talk about adapting some AI functionality for our data dictionary and translation tool. So it's all yours, Maria.
Perfect. Thank you so much. It's great to be with you all today. Yes, you can just dive into the next slide if you would. So Olga has chatted a little bit about a problem that happens with all the data dictionaries as they get larger. Unfortunately, it's very fundamental to be able to efficiently compile and build upon from multiple studies, right? But however, as the data dictionaries are living language, basically, they're ever evolving, new tech is being developed. It can be difficult to search and manage, right? It seems trivial, but in the end, this problem is not actually all that trivial. People need to be able to match their questions of interest to the data dictionary efficiently. So we're addressing that problem using 2 different methods. We already talked about the UMLS code assignments. It's a semi-manual assignment to different data elements. Basically, this is going to be grouping data elements by UMLS concept, so we can begin to search more programmatically. But there's another way we could potentially look at this, and it's a little bit newer method. This is using semantic similarity searches. And you're basically using a pre-trained large language model to transform a data element text, associated text, into a numeric space, which you'll see on the right-hand side. So each one of those dots is basically a BRICS data element. And then the key is they actually will, if the data model is good, they will cluster together. And you can find different data elements just by searching that space. Can you go to the next slide? So yeah, why we need to do this because traditional searches are limited. It's pretty well known one in two important regards, right? So the first one is mainly complex text, such as behavioral questions, which are often associated with data elements, don't usually perform well, particularly for partial matches, etc. So we'd like to cut and paste this question about amphetamine use directly to be able to search our database. This is actually the data dictionary online. It's a fine search tool, but it's more traditional. And I know that data element exists, but yeah, it has a very, very hard time finding it. The other one is, as we were saying, we were trying to use for the UMLS as well, but semantic similar common data elements that aren't spelled the same, but are clearly related in their meaning aren't going to come up in a partial match search. As we come back to traffic accident due to substance abuse, again, the traditional methods freak out and are like, no, there's nothing in there. And we know for a fact that that's not true, right? And substance abuse can also, you would want to find alcohol, you want to find marijuana, you want to find a number of different things. So if you go to the next slide. So that's, again, the solution is these semantic similarity searches using the pre-trained large language models. So we completed an internal proof of concept of this so-called AI tool for searching the FITBER dictionary. Currently, this is NIH access only. I will demo it today. I'm working with ops to hopefully optimize the workflow, etc. But yeah, we are in progress in productionizing the AI tool for release and integration into the public site and potentially other instances. So with that, I am going to share my screen and show you some magic. So here we go. Can everybody see my screen now? So
Yes.
here we come back to this traffic accident due to substance abuse. I've already searched for this going forward. So you have a couple things that you can move around, the number of results to return. Also, the nice thing about this type of search is it will give you a similarity score, 0 being the least similar, 1 to the most similar. It can do that because it's measuring essentially how close it is in that embedded space to each other. So I usually keep it at 0.5. Yeah, and so then what we can see is, yes, it did not freak out. It was like, I can handle that. And these are all data elements, common data elements that are in the FITBER dictionary. Yeah, and so you see it's very nicely, even though it's called substance abuse, it found drug traffic accident and drug influence, alcohol, whether it was somebody else, a party drug. And then it begins to kind of deviate a little bit because this doesn't contain traffic, right? Or there'll be something a little bit different. So yeah, so it's grouping things that way. Often we don't want to just keep on cutting and pasting. I mean, sometimes it's nice just to do a quick thing, but usually we're going to have like a full CSV of these data elements that we're going to want to try to match to the dictionary, right? So what we can do, as I said, this is still in progress. We're hopefully going to be making this much more efficient. But right now we have a batch mode where you're able to basically upload a CSV file. This is my CSV file. It's actually something I know that's in the system for the most part anyway. This is the assist form, which is a collection of data elements. What I'm going to do is try to, I'm going to select preferred question text because that's what I want to use as a query. It'll come with these are all in batch. So I can go and click on these one by one. As I said, we're going to try to do more automated matching when we go forward. But yeah, this is the same question that our traditional data element dictionary freaked out on, amphetamine question, and it's able to find it, perfectly fine using the similarity search. Yeah, so we'll say, okay, I like this. I check out what we can do is end up to hopefully start annotating. As Matt was saying, we start doing some cross mapping. We're going to optimize this process, hopefully, but traditionally you want to be able to save this match. I mean, I can't just remember it, so I can save selected row as a match for later. Yep. Oh, I'm sorry. I'd already started matching some things apparently before. It's going to save your matches, right? And you can basically you can also put notes. This is just has all the information about the data element. This is just notes about comments in case you want to share with anybody else. And you can always download this file at any time. And you would then be able to go on to the next search, do the same process. And as I said, we want to do more automated mapping, but for now, most of the time you want to actually like vet the results at this point and then select which one's the best. Usually it's the top one, but you're still like vetting the large language model. I guess the only other thing is sometimes you might have a new data element, right? It's a new living language is evolving. So I put this random thing. If you could be Batman or Robin, obviously we do not have that data element or behavioral question in the dictionary. But yeah, so it's just to show you, right, there's not going to be results found. You can try reducing the cutoff score to see if there's anything similar that you might be missing. It's funny, it actually goes to combat stuff for Batman and Robin, which I find funny, and like robberies and things. But yeah, obviously none of these really match. So I am going to save user query as unmatched. And again, we can optimize this process but download it anytime. So this is the beginning of the cross-mapping, optimizing cross-mapping. Yeah, so I can stop sharing now.
You do have one question.
Oh, yes. Please. Yeah.
So if you can see the chat.
Does it bring up UMLS concept to save in the match? Yeah, well, so we're working to integrate the UMLS. Yeah, it does actually. If it's labeled, it will bring it up. We are working to actually integrate UMLS concept like under the hood to actually help the search as well. The problem, we don't initially want to filter that immediately because not everything is annotated yet, because the UMLS assignments are kind of an arduous process. So does that answer your question?
Well, I guess I just meant if you do have a colon in your match for UMLS concept, if it's linked.
Oh, yes, definitely.
Yeah. So if it's there, it will show up.
Exactly.
Mm-hmm. Thank you.
Yeah, of course.
I forgot, I'm not sure, maybe it was mentioned by either Maria, Olga, or Alexandra. We're now also able to add UMLS concepts to the permissible value. So that adds a little bit more programmatic analysis or automatic AI analysis of both the data element and the permissible values of the data element.
Yeah. So Preeti, can you I do have a couple slides just because we do have a minute that help kind of bring things together. Can you put those up?
Yeah, sure.
I want to open up the questions to any of the speakers today. We cut off the UMLS talk there just to make sure Maria had enough time. But any questions anyone have, or this is kind of a good time to ask. But go ahead, Maria.
Yeah, I will just say, I mean, it kind of comes all back together, the two sides of the coin, right? Actually, the human vetted UMLS concept labels can actually be used to confirm our LLM performance. So what you're looking at here is just the Fit for Data dictionary in embedded space. It's a vector of 768. It's much larger than this, but UMAP is nice and is able to actually transform that again into a 2D representation. And so the nice thing is, like, when I actually search data elements that have been labeled for alcohol consumption or illicit drugs or laboratory procedures, even though I haven't used anything about the concepts in the semantic search, they tend to group together. So then we know that this is the semantic search is being able to, yes, I'm working on trying to vet trying to figure out a good numeric system, like a good quantitative system. But yeah, so this is the first step though. Alcohol consumption, illicit drugs tend to group together. And as I said, each one of these is a given data element. So that's a good sign to begin with. I think I saw in the chat about people wanting to discuss more about how we would vet this. And yes, it's hard to quantify, and I'm happy to discuss strategies with people going forward. So, okay, that was my spiel. Yeah, first I'll take any
Okay.
questions, and then I can chat a little bit more to any of the speakers.
All right, that's great. Oh, so you have some more, Maria, that you want to talk about?
Yeah, I mean, I just wanted to say where we're going, right? I mean, we want to make common data elements easy to search and harmonize, you know, because we need to focus on scientific discovery. We don't need to be constantly focused on organization, right? So as I said, we're completing the testing and validation of what we have. We're going to I've already started integrating additional filters on form, permissible values, UMLS concepts. It's worthy to note, just because you're implementing a semantic search doesn't mean you can't take some of the traditional search methods. You can get the best of both worlds. Yeah, Matt mentioned this cross-mapping tool, which the general principles is you have a form. It's very similar to what Henry's doing to some extent, being able to put it into bricks format. What we want to do is integrate the semantic search, so you can potentially reduce redundancy and actually use some of the bricks data elements that are actually in the dictionary already. Yeah, and I mean, I think that's pretty potentially facilitate other data dictionary harmonization efforts. I've talked to a lot of people in preclinical versus clinical TBI. The semantic search helps with that. Yeah, and we're going forward and developing other AI tools actually for more efficient data discovery. Very similar principles are the first step to some of that. So thank you so much.
That was excellent, Maria. Thank you. Any last questions for anyone before I just tie up the meeting? Well, it doesn't look like we have any others at the moment, but again, feel free if you think of something that you want to ask one of the the team members here. Feel free to reach out to them directly or to any one of us on the BRICS team. I just wanted to I think Maria touched on is that really the BRICS team, the BRICS system is really about supporting NIH's strategic plan for data sharing and making data fair, findable, accessible, interoperable, and reusable. And we're not only the core part of BRICS, we're trying to address all those requirements, but also in the tools that are kind of ancillary to BRICS, but support the collection and submission of data to the BRICS system, or even the analysis of the data in the BRICS system. We're always trying to improve both the usability, performance, and add the new functionality as needed. It's really been accelerating. We expect to really move forward very quickly over the next year and adding new functionality, including Globus, which will improve the performance of uploading and downloading data from BRICS instances. We are also upgrading the RAS functionality to support passports and to implement functionality to connect efficiently to dbGaP. So lots of new things. Our next version of BRICS that's coming out will be in early December. But we will see you next month at the November BRICS working group. So thanks, everybody, and have a great rest of the day.
Thank you all.
Take care. Thanks for coming.
Thank you. Bye.
Bye.